Good morning, everybody, and welcome to this first webinar, placed slightly later than usual for our Southeast Asian customers. So my name's Craig Harrison. I'm the Service Manager for Europe, Middle East and Africa. And I'm just going to spend a little bit of time today running through our Maestro system and how to use that SCADA package in order to get the best chicks out of your operation and out of your hatcheries. If you've got any questions through today's webinar, please use the Q&A button down the bottom of your screen, and we'll get to those questions as we progress through the presentation. And if we have any time, we'll review those towards the end of the webinar. So today's presentation is going to be split into a couple of different sections. First of all, we're going to quickly visit on exactly what a SCADA system is, so what the Maestro system is meant to be doing and how we accomplish that within our software package. And then the bulk of the presentation today really is how to delve into a little bit more information. How to delve into a little bit more detail into the information that the Maestro has available to it in order to get the best chick possible out of your operation. So that's utilizing the information that's readily available and just knowing what to look for in order to get the best quality. So what is a Maestro system? What is it meant to be doing for your operation? Broadly speaking, we can split this down into three different categories. First of all, the idea is it's going to give you a simple, broad overview of your system operation. So at a glance, in one quick look at the screen, you can see what your machines are doing at any given time, which ones are in alarm, which ones are functioning as you expect, and is an easy and simple way to spot anything that's not going according to plan in your operation. The system should enable alarm monitoring and recording. This is so that you guys can be notified of faults and identify what those faults are on your machines before it causes a problem to your production and a potential loss in production value to you. And the third aspect of this is to ease and simplify hatchery operation. The SCADA package should always complement any work that you're doing within your site. And if you're finding that that's not the case, there's bound to be a portion of the Maestro system that you can utilize to help simplify that. So before we go into too much detail on the Maestro system, it's worth covering the basics. Now, when you first load up the Maestro system, you're going to be greeted with the hatchery overview. Now, this gives you a very simple, broad overview of the hatchery. There's a couple of colors that you're going to see your machines being denoted in. The vast majority of your machine is going to be nice big white squares. That denotes that the machine is nice and healthy. There's no active alarms on it. You've got communications to the machine and the machine's running as expected. And if any of those machines trigger a red, such as the machines down on the bottom of this picture, that shows us that we've got an alarm on that machine. If it's a temperature value that's highlighted, that tells you which zone in the machine that alarm is for, and we can delve into the machine in a little bit more detail, which we see in a few slides time, to find out exactly what those alarms are. If that alarm's been muted, so the alarm has been silenced for duration at the machine level, then that red machine will then go orange. If you've got a machine that's blue, that denotes a loss of communications. So it might be that the machine's been turned off for maintenance, or there's a fault on the serial communications that's sending that information back to the Maestro system. The last color available on this screen is yellow, and that's for a machine that's out of service. And again, it may be because your operation is not full, especially in a single stage. You're going to find setters and hatches that are yellow at times whilst they're being cleaned and maintained. Or it might be that on a classic, on a multi-stage operation, you've got a machine down for maintenance, and as a result, it's been placed out of service by your maintenance crew in order to rectify that. Now, as you travel along the menu bar across the top, one of the most important things to be aware of on the software is in that very top left-hand corner where you have a date format. This number, so in this case it's the 22nd of August 2017, is the version number of software that you're currently running in your hatchery. Now, this software is freely available from Chipmaster. If you go to our website, there's a link there, and that'll be linked in the webinar section of our website after this webinar as well. And that's a free upgrade to ensure that you're on the latest version, and we always recommend you stay on the latest version, so any bugs or enhancements have been improved within the system. As we move across that bar, you've got some information on your license, so just to know exactly where your site is, and that helps us to identify any problems specific to your site. As we go across, you've got a button for the power meter, so you can flick what you display on the screen, whether it's the hatchery map, or if you're going to display the power savings and power meter of your machines as your machines are operating. A little bit further along, we start to get to the real content, so how you can navigate the information that's available to the Maestro system. And the first button we have here is for the graphing, which we'll go into a little bit detail in a moment. Button next to that is for the alarm log, so that's simply to pull up a history of the alarms that have been triggered on your machines, so you can delve into a little bit more detail on them. And again, we're going to touch on those in a little bit more detail in a moment. Next one along is for your calendar or the scheduler. And then the final fourth button there is for your remote alarm screen. And again, we're going to go into a bit more detail on that in a moment. The third group of buttons along this top, the first one is going to be used widely by our multi-stage customers. So this allows you to send and receive set points from the machines. So this button is great if you want to change an individual set point in a machine. And then the final two on that one are for stage programming control. Now the last set of buttons along this top bar, we have the legend. So this is a key to help you understand exactly what the iconography and the symbols within the program mean. And that legend's translated into multiple languages to make it really easy to understand for people that don't necessarily have a native English tongue. Second button on that last group is for alarm acknowledgement, so you can momentarily silence alarms from the Maestro system, and depending on the control on the machine, that information will be translated onto the machine as well. So you can silence the alarms on the machine for a short duration. Second to last button is a ledger view, and this is a screen that's very much like the ledger view on the Galaxy software, for those of you that remember back that far. And this gives you a list view of how your machines are currently behaving. So it shows your heating, your cooling for all of your machines. It's great for spotting hatchery-wide problems with your machines. So maybe a HVAC system is playing up and your room temperatures or your room pressures are a little bit out of spec, in which case you can see the heating and cooling load on all of your machines at the same time. And then the very last button across this top is for engineering configuration. Much like the set points and the stage profile information, this allows you to send and receive en masse the engineering configuration for our latest rock machines to all of your machines at the same time. Again, we're going to delve into a little bit more detail on that later on in the presentation. So when you delve into a room in a little bit more detail, you get a little bit more information for all of your machines. So here we can see not only the current temperature readings on the left-hand side of each machine, but also the set point for the temperature in zone 1 and 2, and also the humidity set point for all of the machines on this setter corridor. And this hatchery overview really gives you a quick at-a-glance information. So straight away you can see which machines are in alarm. Now in this particular demo there's lots of machines showing in as alarm, and just so we've got something to show you on the presentation. And we can see one machine on the bottom right hand corner that's currently grayed out, so that machine's out of service. It could be for maintenance or because of a breakdown on that machine. Now the alarm monitoring of the Maestro system is a really strong aspect of the program. So when you click on that button on the alarm on the menu ribbon across the top, you can very quickly see which alarms are currently active on your machines, and you can filter those alarms. So using the buttons along the top of this menu box, you can turn alarms off, or you can turn them all off at the same time from your viewpoint, and just enable the ones that you want to see. So if you just want to see which machines currently have an active over temp alarm, you just make sure you've got a tick next to that box only, select the selected machines in the top left corner, and it will filter those alarms down for you. So again, it's a really quick and easy way to spot your currently active alarms, and you don't have to scroll through a list of your history of alarms in order to find out what's currently active. Now if you want to export this information to a CSV file, so you want to back up this information, or you want to do a little bit of analytics on your most common alarms, or which machines are most commonly alarming, you can do through the file menu. The next button across that top ribbon is for your remote alarm screen. Now this is a great feature in the Maestro system that allows you to export that alarm information. So you can have an alarm screen remote to the main Maestro PC, and by default we supply all Maestro PCs with a 50-foot HDMI cable. So that allows you to put that screen in an area of the hatchery with high foot traffic. So maybe in your chip processing room or your egg store or your canteen, your staff room. And then when an alarm is active in your machine, you don't have to go all the way back to the hatchery office where the Maestro PC is to get the information of where that alarm is. So it saves you a lot of time in the hatchery running backwards and forwards just trying to identify where that alarm is. So you can rectify it that little bit sooner. Next feature available, if you've got the all alarm, is an optional extra on with them to go with the Maestro system in your incubators. This acts as a remote dialer. So when an alarm becomes active in the machine, it will phone out to a series of numbers that you pre-program into the system just to notify you that an alarm is active in the hatchery and what that alarm is. Built into the system, you can record your own voice messages as well, so you can have custom messages to different people and for different alarms. Again, if you have this system or it's a system that you're interested in having in the hatchery, is a great way of expanding on your hatchery operations, especially for those of you that don't necessarily have staff in your hatchery 24/7. And if you're interested in that, I recommend you get in touch with us and we can give you a little bit more information on that. Now, built into the Maestro system itself, we do use an email server that's built into it. So we use a program that's linked through Firefox that allows us to send emails and text messages from that Maestro PC. So using the contact center, which you can see on the left-hand side of this page, you can pre-program the system with different email addresses and different phone numbers, and the alarm information will be sent to you as it's triggered through the Maestro system. Again, great for those of you that want a 24-hour cover of your hatchery without necessarily having staff in the building. Once you've configured the different contacts in the Maestro system, you can set them up as a hierarchy. So it'll first cycle through the first person, and then the second person, then the third person. So you can have your staff tiered. So that is, the alarms will go to whoever's on call, and if they don't necessarily respond to the alarm, or the alarm isn't cleared in a timely manner, it will then default to the second person, third person, fourth person. So you can be sure and confident that your alarms are going to be addressed in the hatchery. So aside from the normal hatchery operations, what we really want to do is make sure that the Maestro system is complementing everything that you do. So the Maestro system has the ability, as you'd expect of any SCADA system or any BMS system, building management system, to send and receive set points from all of your incubators. This is done through a handful of different screens. So these demos that we can see here, everybody that's got the Maestro system should be familiar with these, so we'll not dwell on these for too long. But these are the set point screens for a number of different controls. Now it is possible, I should note at this point, to do all of your set point and all of your stage profile control to multiple machines at once. So you don't have to sit and program one machine and then program the next and then the next and then the next. So if you're a facility that's block setting your machines, which most of us do, you can hold down control and click on multiple machines, and as with the picture on the right hand side here, you can see multiple machines have been selected, and any programs or any parameters that are updated will be updated on all of those machines at the same time. So as I said, the set point screen, even if you're running a stage profile, is a great way of changing just one or two parameters at a time on one or multiple machines. And this is ideal if you've got maybe a high temperature alarm or a low temperature alarm, or you just want to tweak a damper in those last few hours of a hatcher profile or the auxiliary blower in order to get a little bit more cooling duty through those machines. The next button along, as I said, is going to be your stage profile. So here we can see a stage profile for the generic 3, which is limited to 10 stages. And then on the right-hand side, we've got a far bigger stage profile available, and this is from one of our more recent ROC controls. Now, the different parameters that you're going to see on the stage profile depend on the control that you have. So you can see we've got a lot more parameters to change on a ROC control than we do on a generic 3. And that's just because the control is far more flexible, and we can change a lot more things to ensure the best possible production through that control. There's a key at the bottom of the screen just to help you identify exactly what each of the settings are. And then the particular cell that we're currently on is highlighted with the green lines. And it's just a simple case of typing in the value that you want into those boxes. Once you've got that profile set up exactly as you like, you can back those files up. So you can save this file to the PC with a custom name, and then it makes it very simple for your hatchery operators, so your staff, to pull up the correct profile as and when needed. Because we recognize that you're not always going to want the same profiles in the same set point in your machines. You're going to want to defer or delay your transfer window, maybe bring it forward, push it back. You maybe have different damper profiles to allow for different humidity and different weight loss profiles for different flocks and different age flocks. The last screen we can see here is that engineer mode. Now the engineer mode allows you, as I said, to export and then, upload and then download engineer settings for multiple machines on the rock control. Now this is great if, for a couple of different reasons, if you want to tweak the settings of your heating and cooling characteristics for your machines, or how the fan operates, or how aggressive your cooling valve solenoids are inside the machine, or for instance if you've got a PLC or control that you've had to replace on a machine and you want to very quickly get that machine up and running. All you need to do is replace the PLC, set the node address so that it's going to talk to the Maestro system, and then you can put a known good configuration into that machine, and your setter or hatcher rather is then running really quickly. So the scheduler I mentioned earlier is a really strong function of the Maestro system that is underutilized. And it's something that we're working on at the moment in order to bring some further enhancements to this. So the scheduler allows you to put different tasks into the diary built within the Maestro system, and then these can be set to remind you as those tasks are coming up. And these tasks can vary between maintenance tasks, egg setting, egg transfer, miscellaneous, or hatch tasks as well. So if you want to set up your hatchery operations scheduled on the calendar, you can do, and it will remind various staff or different teams within your facility of what tasks they need to accomplish in that day or in the week coming ahead. All of these tasks you can put down to reoccur. So that is, you can set it so every 2 weeks you're going to have the same tasks come up, or you can have it sort of once a quarter, once every 6 months, in order to remind somebody to oil the bearings or check the belt tension or to calibrate machines. Now all of the information I've just covered is available in the manual for the Maestro system, and this is the sort of the bare minimum I'd say you need in order to learn the Maestro system. And if anybody's got the Maestro system here, which most of you probably do, it's highly likely that you're well aware of the content that we've already covered. Now what we're going to spend a little bit more time on now, we're going to delve into a bit more information on exactly what you can do with the information that's freely available within the Maestro system in order to get the best production value out of your site. So one of the great quotes I like by Andy Dufresne is, you can tell a lot about a man by looking at his shoes. Now as far as Chickmaster is concerned, you can tell a lot about a chick by looking at his graphs. So that's what we're really going to focus on here now. Most of the information in the Maestro system is the graphing, is the value of the graphing within that program, and that can tell us an awful lot about how those machines are performing, and particularly how those chicks are doing inside that machine. Before necessarily, a lot of the time, before those chicks are aware of exactly what's happening. First thing to be aware of, to find what you're looking for, you're going to need to know what you're looking at. So what I mean by this is, whenever you're looking to set up a standard for your hatchery, you need to know what you're looking at. You need to know what good looks like. So it's highly recommended, whether you've got a new flock coming through the hatchery or if you're just starting to learn with Chickmaster machines, whether it's single stage or multi-stage, you build up a catalogue of known good graphs for your machines. Now this is important for a couple of reasons. The first is, if you look at a graph of a machine and it's got a problem in it, you're not going to know what it should be. And so identifying that problem and identifying the change from normal is going to be really difficult to do. The second reason is, looking at the graphs and understanding exactly what they mean is a great way to understand exactly what's happening in those incubators. And it's vital, from my point of view, for new staff coming through your hatchery, or even staff within the hatchery that are transferring onto the chick side of the operation, to understand really the mechanics of the machine and how that interacts with the bird. So a couple of the graphs that we can see here, on the far left-hand side, we've got the first 12-hour warm-up period for a setter. So this is a 24-hour graph that we can see here. You can see spot in the middle of that graph, you've got a nice gentle curve as that machine comes up to temperature. Now straight away from that graph, I can tell that that's a setter that does not have hot water heating installed, because if it did, what I expect is that temperature, that warm-up profile would be considerably shorter. Instead of 10 to 12 hours, as we can see here, I'd expect that to be 4 to 6 hours. Now the middle graph is a 7-day graph, so it's a slightly different resolution, so it's showing a lot more, but these 7-day graphs are great for spotting elongated trends throughout the setter. So whilst you're not going to see the individual blips in temperature because of the resolution of the graph, you can see that by and large the damper and the humidity and the temperature are well within the parameters of what we'd expect for those setters. Now the very last graph is a 7-day graph for a hatcher. So this is one that was transferred at 17.5 days, and straight away you can see the pipping of the eggs in that one, in that hatcher, sorry, by that very obvious peak in humidity. So for what I'm talking about for the humidity, sorry, is the green line in the middle of that graph. So you can see where that humidity peaks. The length of that and the height of that will give us an indication of both the hatch window and the fertility of that flock. So the first example I'm going to go into here is delving into a bit more information on that warm-up time for the machine. So again, here we can see the same graph from that overview screen. But if we compare that to a different machine where we've got a slightly different profile for your temperature here, so what we can see is zones 1 and zone 2 in this machine are taking a little bit longer time in order to come up to temperature. This isn't what we want in the machine. Ideally, what we're after in any setter is all of the eggs in that machine coming up to temperature in as short a time period as possible. The main reason for this is for uniformity. The main component or the main contributor to your hatch window, so 21 days down the line, is the amount of time or how closely all of those eggs get up to incubation temperature compared to the eggs next to them. So if you're finding 1 zone or 2 zones or even 3 zones of your machine are getting up to temperature at different rates, that's going to have a direct measurable impact 3 weeks down the line when you start pulling those eggs out of the hatches. And if you're then putting green chicks or dehydrated chicks onto the farm, again, that's going to have a direct impact on your 7-day or your 10-day mortality. So when you see a graph like this in a setter, what is it you want to be looking out for? Usually what we're finding is that you've got 1 or 2 zones that are lagging behind on temperature because of a faulty heating element. Maybe if you've got solenoid valves for your cooling rather than a modulating valve, maybe you've got a little bit of flux or the diaphragm within that valve is leaking, in which case we're perpetually cooling a zone and the machine's having to fight itself. If you're finding that zone that is slow to come up to temperature is in maybe zone 1 or zone 2, it could be that you've got either a leak through your air duct, a leak through the gasket around your door, in which case that's just a case of preventative maintenance in order to replace that, or maybe your damper coming into the zone isn't calibrated correctly or isn't set up correctly, and as a result we're dragging some fresh air into those zones and pulling the temperature down a little bit. Now what you'll often see if you've got this problem in your machine, especially if it's a mid-zone machine, so that is zones 2 or zones 3 on a 4-zone machine, is you'll see the neighbouring zones next to the zone with the problem also dragging their temperature out a little bit longer. Again, as I said, comparing this to a known good machine is a great way of spotting this early on. And if you can spot this well before that it's got up to temperature, so maybe you're spotting it 4 or 5 hours after set rather than 12 hours after set, it allows you to fix that issue and again bring those temperatures back closer together, and that'll save you a lot of heartache further down the line for your hatch window and your chick quality. Now the next graph we have here, again this is the known good graph that we're going to compare it to, but then we have the comparison graph, which is when the entire machine is taking considerably longer to get up to temperature. If you've got hot water heating on the machine, and the entire machine is taking longer to get up to temperature with a nice gentle curve like this, that would indicate to me that your hot water system isn't functioning as designed. So what we want to be looking out for here is strainers on the system. Make sure your pressure differential across the machine is adequate. So to make sure you've got that 2.5 to 3 bar differential across the machine on your hot water system. So when I talk about pressure differential, what I mean is your pressure of the water going into the machine, so the head of pressure, and then the static pressure of the system as it pertains to the suction side of the pump. Now that difference in pressure is what gives us our flow through the machine. So it's important to maintain that at 2.5 to 3 bar, or around 45 psi, in order to ensure that we've got adequate flow. If that differential reduces, what you're going to find is a corresponding reduction in flow, both of chilled water and hot water, through your machine. So it's important to maintain. It could also be bad configuration. If you've had staff playing around with the settings on the machine and they've maybe disabled the hot water or increased the hot water offset, what you're going to find is this sort of profile on the machine where the entire machine just takes a little bit of extra time to get up to temperature. There's two side effects to this. The first is on your hatch window, because the egg mass takes a bit longer to get up to temperature. It's going to split your uniformity out a little bit extra, and also it's going to defer the entire hatching age of the eggs. So whereas you may expect them to come off at 7 o'clock in the morning out of the hatches, when you come to pull those chicks, it might be that they're not quite green enough yet, and they need an extra 3 or 4 hours in that incubator just to finish drying off before you can stick them in an egg store. And that's something you can spot readily and easily before you pull them out of the incubator, and we're going to go into a little bit more detail on the hatcher graphs in a little bit. So this is the item of the graph that we're looking at here. So the next graph that we can see here, what we're looking for really is the heating load is denoted by these bars at the top. So at this point, it's really worth stopping and just looking into the graph in a little bit more detail. So if we start at the top of this graph and work our way down, the first 4 lines that we can see on this graph show us really how much cooling this machine's doing. And this is a percentage of that time frame. So if we were cooling in any of these zones for the entire duration of this graph, what we'd see is one solid bar all the way across that, and the value on the left-hand side would be around 100%. But what we can see on this one is we've got zones 2, 3, and 4, 17, 15, and 14% respectively, but then zone 1, which is always coloured red on our graphs, is sat at 30%. So that's doing about twice as much cooling in that zone 1 as to the other 3 zones in the machine. We'll come back to this in a moment, but as we move further down the graph, you can then see your temperature profile inside the machine. And again, you've got all 3, or sorry, in this case, all 4 zones in the machine overlaid on top of each other. And then a little bit further down, you've got the heating duty inside that machine. As we travel down the graph, your green lines denote your humidity in the machine, and then at the very bottom of the graph, we've got a blue line which shows us our damper profile. Now, dotted lines on our graphs are always denote either the high alarm or the low alarm or the set point for a value. So that's much the case with the humidity and the damper. And then solid lines are the actual reading from those field devices. Now, if we go back up to the top of the graph, we can obviously see that zone 1 is is cooling twice as much capacity as any of the other zones in the machine. So if this is an early stage in the machine, this tells me usually that the machine hasn't been calibrated perfectly. So it may be that the calibration value for that zone is a little bit higher than it should be, and as a result, the machine is trying to drive that temperature down, but it's having to fight with the other zones in that machine. So again, knowing what's good and what's normal in a machine and comparing it to what you're seeing is a great way of spotting this before it's a problem. If you're not looking at these graphs, the earliest indication that you'd have of this machine potentially being a problem is 21 days down the line when you pull those chicks out and you find that your uniformity is way out of spec and out from what you'd expect. Now, it's not to say it's always calibration. It could equally be that you've got a faulty heating element inside one of these zones, or a burnt relay. So your solid state relay might be stuck on, in which case you're constantly heating those zones, even though the control's not asking it to. It could be that you've got hot water leaking into the machine, or it might be that the damper for that zone is stuck all the way open or stuck all the way closed, in which case the control's having to artificially, or it's having to cool that zone in order to maintain the temperature. But again, spotting the problem is the first step in order to diagnose exactly what that problem is and fixing it. So there's that section of the graph in just a little bit more detail zoomed in. So I know not everybody's on a big screen. And again, you can see very easily and very readily that nice thick bar just denoting exactly when it's heating and cooling. Now you'll notice here we're on a day graph. So this is a 24-hour period that we're showing. If you want to see in a lot more detail, so a greater resolution for those figures, I highly recommend that you do your investigating work on the Maestro system on either a 4-hour or a 1-hour graph. And that'll have physically more information points or more data points on the graph, and you'll be able to draw much clearer conclusions from that information. Whereas the day, the week, and especially the month graph, whilst they're great for showing trends, it may be that you're missing peaks and troughs in that information and little blips that are filtered out just for ease of viewing on the larger graphs. So on this graph here, what we're really looking at is the humidity level in those early stages. So for the humidity, as I mentioned earlier, what we're looking at is the green line about halfway down this graph. So this again is the known good. So the humidity is perfectly on the set point and it travels along that line nicely. And what we're seeing is the blue line further down the graph of the damp, which denotes the damper, which is constantly searching as it's meant to be doing in order to maintain that humidity level. And the reason that the ventilation requirements of the machines changes is twofold. First, you've got environmental changes around the machine. So as staff go in and out of the machines, you're going to find that the air profile or the air available to the machines changes ever so slightly, and equally the needs of the embryos are changing inside that machine as they develop. Now, so if we compare that to the second graph, what we can see here is that the humidity level never quite reaches the set point inside that machine. So the humidity level is way below where we'd expect it to be at this stage of incubation. As a result, the damper position is constantly sat on its minimum set point. So the control is trying desperately to get that humidity level up to where it needs to be, and it's just not quite getting there. Could be for a couple of reasons. If you're in a really dry climate, so your hatchery is at a high elevation or it's in the middle of a desert, you're naturally going to have a problem with maintaining humidity levels. So it may be that your humidity system or your central humidity system in your hatchery isn't functioning optimally, and as a result your humidity level in the machines have taken a little bit of a hit. If normally humidity is not a problem in your hatchery, then maybe they were over-ventilating this machine, and that can be for a couple of reasons. Either your HVAC system isn't configured correctly, so where the negative pressure in the plenum of these machines on the exhaust side is a little bit higher than what we'd expect, or it could be that your machine or this individual machine has got a leak. So again, we're back to the door gaskets on the front of the machine, or the gaskets on the dampers on the top of the machine. And being able to spot this is the first step in order to fixing this. And the worst case is 6 months down the line, you find that your weight loss for your chicks isn't what you'd expect, and the company veterinarian comes at you with a graph that says, you know, we're hitting 14% weight loss or 6% weight loss, where we're really aiming for 10 to 12. Why is this? You can be really proactive with this information and spot it before it's a problem, correct the issue on the machine, and then you're back to the previous graph where your humidity is exactly what you'd expect. So what we're looking at on this graph is days 8 to 12. So really that middle portion of incubation in the setters when the eggs start becoming exothermic. And what we're looking here for is the stability of that temperature profile as the eggs progress and start becoming exothermic. Now the reason we look at this portion of the graph is because we're changing the heat characteristics of the egg. In the first week of incubation, we're really putting heat into the embryo, so it's absorbing that heat and using it to kickstart that cell division and the growth of the embryo. And through days 8 to 12, the egg's becoming exothermic a lot more. It's generating heat, and the setter cabinet itself changes from being a heating cabinet to becoming a cooling cabinet. So those days 8 to 12 will really tell you how well the cabinet is controlling that and how it handles that transition. And what we're looking for is a nice continuous, stable temperature inside that cabinet. If you don't see that, that's a great early indication that either your settings in the cabinet are a little bit too aggressive or not aggressive enough for cooling, or equally that you might have a leak inside the machine or a fault inside that machine that's altering that environment. So for this graph here, what we're really looking at is the very bottom portion of the graph, this blue portion which denotes the position of the damper, which handles the amount of fresh air that your incubators, whether it's a setter or a hatcher, is going to have. So the axis on this graph has been changed slightly. So the damper graph is actually showing 0 to 300%. Now obviously the graph's never going to reach 300%, it's going to cap out at about 100%, which means that this graph is nicely nestled in the bottom portion of this graph, so we don't have multiple values overlaid on each other. Now if you want to change the axes of your graph at all, there is a y-axis button on the left-hand side of this page normally. It's clipped off on this particular image, and that will allow you to change that configuration to suit your specific needs. And that's a great way of switching between Celsius and Fahrenheit for different customers as well. Now again, this is a known good graph for the damper. And if we compare this to the next graph, where we can see the damper position halfway along this graph sits on the minimum set point, and then it stays there. And again, what we're seeing just above that is the humidity levels are dropping down below the set point as soon as it starts to do that. So again, this is a bit later in the incubation to the last graph that we saw, but this is a very good early indication that maybe we're over-ventilating that machine. And as a result, we're putting far too much fresh air in there, which is dropping the humidity levels in that machine. The counterpoint is we may be overcooling the eggs, so we're having to do more heating in that machine, potentially, than other machines in order to maintain that egg mass temperature. And obviously, anytime we're having to do any supplementary heating or cooling inside the cabinet, that's going to impact the uniformity of the egg mass. So we want to keep that to an absolute minimum, do as much of that temperature stability or stabilization with the fresh air passively going through the machine as possible. So again, the cause for this is likely to be either a really cool, dry room or the differential pressures just being set too high on your plenums. So the next graph we're going to look at, same graph for the same machine during the same period, but we're going to see the opposite side of this. So on this particular graph, what we can see is that in those later stages of this graph is the damper going to 100%. So we're really ventilating that machine aggressively. We've got loads of fresh air going through this setter. And even though we're doing that, or even though we're trying to get loads of fresh air through the machine with that damper open 100%, the humidity level inside this machine is creeping above set point, and then it's staying 5 or 10% above where we want it to be in that machine. And this is a perfect example of maybe the opposite problem for this particular machine. Now, maybe this is a mechanical fault on this one specific machine. So although the control thinks the damper's at 100%, it may have come loose on the spindle. So the damper itself is only at 60 or 70%, but the control thinks it is at 100%. So it's really important to understand when you're looking at these graphs, whether it's a fault on this one specific machine or if it's on a bank of machines within a room. And if you are finding this fault on a bank of machines, then you want to be starting to look at the HVAC system. And in this particular case, what I'll be looking at is that differential pressure, and what we're probably going to find is that it's a little bit too low. So that 3 to 4 CFM per 1,000 eggs that we usually look at for airflow through a machine with the damper at 100%, we're probably going to find if we measured it on this particular machine, it's a little bit lower. So now we're onto the graphs for the hatches a little bit more. So once we transfer the eggs into the hatcher, what we're really looking for, first of all, is the amount of heating that needs to be done to those egg mass in order to get that entire hatcher cabinet up to temperature. So if we compare these two graphs, what we can see here is those bars that denote the heating in the zones are heating for a lot longer in the second graph compared to the first graph. Now, it's worth noting at this point that this graph shown is for a 2-zone hatcher. There's not many of them out there in the world, but the customers that have them do love them. They provide a really nice stable temperature for your egg mass, and also because of the sheer amount of eggs that you've got in there, helps to stabilize the environment that little bit more. But what we're seeing here is roughly twice as much heating into these machines as what we'd normally expect. So what do we need to be looking at here? Either faulty heating elements, because in reality the amount of exothermic heat that these eggs are giving off in these early stages on the hatcher should have absolutely no problem getting up to temperature. So the fact that we're having to do several hours of heating to get it to temperature tells us that something's really gone wrong. So potentially a mechanical fault on the heating element, or maybe we're back to over-ventilating that machine. But on this particular machine, you can see from the blue line, the damper isn't open a great deal. It's only open around 30% during this period. So again, on this machine, I think it's more a mechanical fault rather than anything else. Now the next graph really brings us to the meat, or the really important portion of a hatcher graph when you're looking at it. And this is the humidity peak that you're going to find in the last 12 to 24 hours. So this green line, and this is the characteristic humidity peak that really tells us a lot of information about the pipping cycle of that hatcher. So again, having a known good for this graph is absolutely crucial. And there's a couple of things you want to know and be comfortable with for your known good graph for your hatches. The first of all is your peak humidity. So on this particular graph, we can see our peak humidity is around 92 Fahrenheit, and that's obviously a wet bulb reading. And on the second graph here, what we can find is that that peak's gone up to 96 Fahrenheit on the wet bulb reading. Now, that additional peak isn't necessarily a bad thing. It could be that for this particular graph, we've backfilled some infertile eggs, or we've got a really fertile flock, a really prime flock. Or maybe that we've just got a different breed of eggs in this machine to what we'd normally expect. But equally, that additional peak could be because there's a mechanical fault on the machine, and maybe we're not ventilating that machine as well as we should do, and as a result, we're not getting rid of that excess moisture that the eggs are giving us as they come out of those shells. So again, knowing what you're looking at and putting it within context of the operation of the hatchery itself is absolutely vital. Now, if you are seeing that peak of humidity far higher than what you'd normally expect, the sort of things you want to be looking at is back to the ventilation for the room. Now, on a hatchery, you're looking for about 12 CFM per 1,000 chicks without the auxiliary blower active. And when the auxiliary blower is active, you want to be looking at around 15 CFM per 1,000. So again, you want to be checking that that auxiliary blower is working and it's configured correctly. There are a couple of different ways of setting up the auxiliary blower, and if you're unsure which one's best for you, drop us a note at support@chipmaster.com and we can help you through that. One of the last things we'd look at on the hatcher, if we're seeing that peak in humidity higher than we'd expect, is the inlet damper on the machine, just to be absolutely sure it's operating correctly, and when we're at 100%, it's actually at 100%. But what we can see on this graph is that it is actually modulating correctly in order to maintain that maximum humidity level. Now the next graph we're going to compare, again we're going to start off with the known good graph here. And then what we're going to compare it with is the length of that humidity peak rather than the height of it. So a normal humidity peak in these machines, so that hatch window, is around 24 hours on this graph for this customer with this flock. And then what we can see on the second graph is that is it's pretty much doubled in length. So it's up to 48 hours. And again, knowing that hatch window is doubled in length, what you're going to find is when you pull those chicks at your normal time, you're going to find a lot of green chicks in there. But not only are you going to find your green chicks that have only just hatched prior to pull, you're also going to find the corresponding chicks that came out at the very start of that humidity curve, which is going to start becoming dehydrated. And they're the ones that are really going to struggle on the farm in the early days, because by the time they get to the farm, by the time they've been transported and put in the sheds, they're going to be really dehydrated and they're going to be really hungry as well. So you're going to have a measurable impact on your 7-day mortality and your 10-day mortality. Now, when you see a hatch window like this, the chances are the bulk of the damage that's led to this has been done in the early stage of the setter. So whilst it's not necessarily a fault that you can correct as you go along, there is a couple of things you can do. First of all, you can pull this machine a little bit later, so your green chicks are fully dried off and they're ready to go onto the farm. And it may be that you can pre-prep these birds and maybe give them a little bit of feed in the basket or a little bit of moisture, raise the humidity levels just to stay off that dehydration as they travel. And equally, it allows you to look back at your records for the setter that these eggs came out of, just to ensure that your calibration and the mechanical functions of that setter are accurate and as they should be for when you're looking at the temperature profile and the warm-up time, so that the next time eggs from that setter come through, you can look to reduce that hatch window back down to something a bit more manageable. So, quick conclusions of this. The Maestro system should be used to complement your existing hatchery operations and really strengthen what you're already doing. It's vital that you become familiar with the Maestro features. So the manual's freely available to you guys, and it'll be on the webinar section of our website after this webinar. So that'll be put up probably Thursday or Friday this week. And if you've got any questions whatsoever, feel free to ask questions in the Q&A at the bottom of the box, which we'll get to in a moment, or drop us a note at support@chipmaster.com if you've got a specific question, and we're more than happy to ask you, whether it's on how to use Maestro or whether it's on how to interpret the data that you're seeing in your specific hatchery. Lastly, and really the lesson I want you guys to take away from this webinar, is to develop a known good reference library for your hatchery. Now, this isn't one graph fits all. If you've got multiple different flocks, different aged flocks, and your different setting patterns in your hatchery, I'd expect your reference library to be full. And I expect you to have a known good graph for all of your different flocks and all of your different ages. And then that allows you, for anybody that walks up to your Maestro PC, to open up a folder and see exactly what known good is, and they can very quickly spot something that's not to spec. You should be comparing regularly. Don't necessarily wait until you find a problem with your chick before you start looking for a problem with your machines. A daily check, so spending 15 to 20 minutes just quickly looking through your graphs, looking through your hatches that are going to be coming off that evening or the next morning, can save you a lot of heartache, and it allows you to address problems before it impacts your chick quality and your revenue for your site. So please, don't wait until you've got an issue, and if you need help identifying problems in your machine or knowing what you're looking at, feel free to drop us a note. So quickly going to go through some Q&As. We've got a handful of questions here that we're going to address. First of all is if it's possible for Buckeye machines using Maestro. The answer is very simply yes. However, it's not, as of most things, it's not quite that simple. It really depends what control you have on those Buckeye machines. So if you've got a Gen 3 control, so that's the Omron PLC with a CQM1 PLC type 51 or newer, then absolutely the Maestro is going to be able to talk to those machines. And if you've got an existing Galaxy system, we can upgrade that very easily and simply. If you've got an older control than that, so you're talking maybe a Gen 2 PLC or older or electromechanical, we're going to have a little bit more trouble connecting those machines to Maestro. But if you've got an older electromechanical Buckeye control or machine, so one of the multi-stage machines, but you've got maybe a GEM control, so the E5 CI on-one controllers, the little square black ones, we are able to put a communications card in those, which will then allow communications to the Maestro. So absolutely. If you want to look at getting Maestro on a Buckeye machine, drop us a note, support@chipmaster.com with some details of your controls and the machines that you have, and we'll do our best to get you up to speed on the software package. Last question is, how many degrees is the temperature you recommend for chicken by the end of the hatch process? Unfortunately, there isn't a simple answer to that one. It really depends on the age of your flock and the type of flock that you have. And I'll reach out to you separately, and what I'll do is I'll put you in touch with one of our hatchery specialists just to give you a specific recommendation for your flock and your machines. And hopefully we'll solve your question for you direct. And that really covers the presentation today. I want to thank everybody for your time today. We're finishing a little bit 6 minutes early. I do apologize for the technical glitch early on. I'm not sure what happened there, but I'm glad everybody got reconnected again and we were able to address the content today. Again, thank you very much for your time. If anybody's got any questions, feel free to drop us a note, support@chipmaster.com. The recording for this webinar will be available on our YouTube channel over the coming days. And as I said, there'll be some reference material that we'll put alongside that as well, just so you guys can really delve into the information of this webinar in a little bit more detail. Look forward to seeing you at the next webinar. We are repeating this webinar next Tuesday at 10 a.m. Eastern Standard Time in Spanish, and then we'll be repeating it again due to high demand on the 18th of August at 10 a.m. Eastern Standard Time for our North American and European customers as well. So again, thank you very much, and I look forward to seeing you all at trade shows once this pandemic is over. Thank you very much.